Let triangle ABC be an equilateral triangle with side length 55. Points D, E, and F lie on BC, CA, and AB respectively with BD equals 7, CE equals 30, and AF equals 40. Point P inside ABC has the property that AP, the angle AP equals angle BFP equals the angle CDP. Find tangent square AEP. So let's draw a figure. Let's try to understand the problem on the figure. So we start with the equilateral triangle. Let's call these sides A, B, and C. And I know that the side length is 55. So let's mark the points D and F. So D probably is somewhere here. E is probably somewhere here. So BD is 7. So DC has to be 48. And CE is 30. And AE is 25. And finally, lastly, the number F is somewhere here, so that AF is 40 and BF is 50. And then next we pick a point P, probably somewhere, I don't know, somewhere like here. And when I just connect P with E and P with F and P with D, we have certain angles are equal to each other. So this is P. So this angle here equals angle here, and that also equals the angle here, right? And we want to find, if we call this theta, want to find tangent square theta. Okay, so first let me just draw a number of sides and just obtain some nice results. So first I'm going to draw FE and ED. And then I'm going to use lower cosine. I know that these angles are 60 degrees. This angle A and angle C are 60 degrees. So when we use lower cosines, I can just consider this part as 8K and this part as 5K, where K is 5. From lower cosines, I get EF squared equals 8 squared plus 5 squared minus 285 285 cosine 60. Cosine 60 is 1/2 K squared. So this is 1/2. When you just replace everything and do the algebra, you get 64 plus 25 minus 40, parenthesis K squared, and this is 49 K squared, which tells me that EF is 7K, and K is 5, so this has to be EF is 35. Okay, when we do the same trick or same thing on this triangle, EDC, we immediately obtain that this part, ED, is 42. And not only that, but also two triangles are similar, right? So the first triangle is this one, EDC, and the second triangle is this one, EF. Why? Because they have the same angles in between and the same ratios of the side, right? So this is 5T, 8T if you like, and the angle in between is 60. So we have side angle side similarity. So those two triangles are similar. And this immediately implies that this angle, if I call it alpha, equals to this angle. So this has to be alpha as well. Okay. Now, another nice thing, or another thing that we can immediately observe is AFPE is a cyclic quadrilateral. Why? Because the opposite sides, opposite angles add to 180, right? Because this angle is theta, so is this angle. So opposite angles add to 180. So this is a cyclic quadrilateral. I mean, if you like, you can just draw a circle so that you can remember that it's cyclic. Oops. Right. So now let me just draw this line. Let me connect A with P. And from from a circumscribed angle, this is also alpha. Why? Because this arc is seen by angle alpha. So APE has to be alpha as well. And again, okay, so when we do the same similar analysis with the points P, E, C, and D. Now, we just observe that they are cyclic as well because opposite angles at the 180, right? So we can just draw a cycle here. It doesn't look like a perfect circle, but anyhow, it doesn't work. It doesn't hurt. And then we're going to connect P with C, okay? And we're going to obtain that this, so we immediately obtain that this is also alpha. So why? Because this arc is seen by angle alpha from the circumscribed angle, so this has to be alpha, right? And those are the two. Now I would like to just focus on this triangle here, APC. In this triangle, PE is an angle bisector, and one side is 25, and this is 30. So this just immediately implies that this AP, if AP is 5 times L, then PC is 6 times L due to angle bisector theorem. Okay, and this is the first thing. And this we have a couple of things to work, but I would like to just lay out my next strategy. So I'm going to just draw the triangle APC in a separate part, and I'm going to tell you what steps we're going to use and find tan squared theta. So first, let me just draw a separate triangle here. So APC, right? We have alpha here, and this is 5L, 6L, it's 25, 35, and we have a theta here. First, I am going to just calculate sine alpha and cosine alpha from the first triangle, or AFE, using the law of sines or law of cosines, okay? So the strategy, so let me lay out the strategy. We're going to do a bunch of computations, so it's a good idea to just lay out the strategy. So first, let's find sine alpha and cosine alpha. And then next, we find cosine 2 alpha. Okay, and then use law of cosines and with cosine 2 alpha and find K. I'm sorry, find L. Okay, next, after we find L, we use law of sines in triangle, so in this triangle, and find sine theta. After we find sine theta, we just find tangent square theta. And this is indeed sine square theta over cosine square theta, right? And this is our more simply sine square theta over 1 minus sine square theta. So this is the strategy, right? We have to just calculate these values. So let's start with sine alpha. So let's look at this triangle, first triangle, and when we use law of sines here, we get 35 over sine 60 equals 25 over sine alpha. Okay, then sine alpha is, I'm sorry, this should be 35. It is, then sine alpha is 5 over 7 root 3 over 2. This is 5 root 3 over 14. And then when we just draw the triangle for sine alpha, we can just easily calculate the cosine alpha. So this alpha, this is 5 root 3, and this is 14. And from Pythagorean theorem, we can immediately get that this is 11. So cosine alpha is then 11 over 40. Okay, so let's write them down. So sine alpha here is 5 root 3 over 14, and cosine alpha is 11 over 14. So cosine 2 alpha is then, let's find it here, it's 2 cosine squared alpha from double angle formula minus 1. And then this is 2, 11 squared plus 14 squared minus 1. And what is this? So let's calculate this. This is 242 minus 196 over 14 squared. And this is 46 over 14 squared. Okay. So this is cosine 2 alpha. And we're going to use cosine 2 alpha here in the large triangle, the APC, and we're going to use law of cosines and find L. Okay, so let's do it. Let's remember this number, and then let me just go to the next page, since we are running out of space. I'm going to finish the problem on the next page. So let me draw the shape here real quick. I think I can just do it. So the shape looks something like this. It's A, C, P, it's alpha, alpha, and this is theta. So this is 5L, 25, 35, 36L, and cosine 2 alpha equals 46 over 14 squared. Okay, now let's use law of cosines, and then this gives, so this tells me that 25L squared plus 36L squared minus 2 times 5L, 6L times cosine 2 alpha equals 55 squared. Okay, so just pull out L squared. The rest is 25 plus 36 minus 30 times, and no, minus 60 times cosine 2 alpha is 46 over 14 squared. Okay, and then this equals 55 squared, right? Okay, and then this is indeed so this is indeed when you just simplify the things, it's just 61 minus 30 times 23 over 49 equals 55 squared. Okay, and L squared times 2299 over 7 squared equals 55 squared. I think this step is the trickiest, the most troublesome step. So this 2299, and you just observe that 2299 is 209 times 11. So this is 209 times 11, and 209 is 11 times 19. So the numerator actually is 11 squared times 19. So we get L squared times 11 squared times 19 over 7 squared equals 55 squared. Okay, and then from here, I think we can obtain that L squared equals, you can just cross out 11 squared, so you have 5 squared. So this is 5 squared times 7 squared, so 35 squared over 19. Okay, yeah, and then now we have this one. So all we need to do is find tangent alpha. All right. So let's use those signs here in this triangle, this purple triangle, and let's see what we get. So all signs here tells me that theta 5L over sine theta equals 25 over sine alpha. Okay, and let's remind ourselves sine alpha, and I think as far as I remember, sine alpha is 5 root 3 over 14. Okay, yeah. So let's write everything down. So let's find sine theta. Sine theta then equals L over 5 times sine alpha, 5 root 3 over 30. Okay, or sine theta equals L root 3 over 14. Okay, and then sine square theta is then L squared times 3 over 14 squared. Now L squared is what? 35 squared. So let's write it down. For 35 squared times over 19 times 3 over 14 squared. Right? And now let's just do the cancellation. So this and this cancel, the 7 squares cancel. So we have 25 here. And we have 4 here, right? So then this is, the answer is 75 over 76. So this is sine squared alpha theta. Okay, we're almost there. So tan squared theta equals sine squared theta over 1 minus sine squared theta. And then this is indeed 75 over 1. And this is 75. And 75 is our answer.